Imagine a whole world where every single choice, from what people eat for breakfast to which starship route to take, is decided by rolling a giant cosmic die. Says Mira, a playful kid with twinkling eyes. She flips a switch on her makeshift probability engine. A glittering prism of mirrors, sensors, and quantum chips. Let's see if we can predict the next move of this random republic. First, she watches tiny robots in her scale model city. Each robot flips a coin its chest every morning to choose jobs, games, even hairstyles. On one block, robots pick basketball with heads, painting with tails. The pattern jumps around wildly, because each flip is truly random, fed by quantum noise inside the prism. Mira giggles when robots in the next block pick painting 3 days in a row, pure charm. But then she gathers data. She builds a giant chart of millions of coin flips from every corner of the random republic. She looks for hidden clues. She learns from statistics class that even random events obey the law of large numbers. If you flip a fair coin a billion times, about half will be heads. Soon, she sees that at a city steer, almost 50% of robots pick basketball and 50% pick painting. In all the whole regions, choices settle into stable ratio: 30% chores, 20% music, 50% sports. Intrigued, Mira asks, "Can I predict tomorrow's overall choices? Even if I cannot say what each robot will do?" She applies the Central Limit Theorem she knows from school. She calculates that tomorrow's share stays close to the day's, plus or minus a tiny wobble. On average, she forecasts 50% spots with a tiny margin of error. She's right, over and over again. The huge crowd averages out the wild swings of single coin flips. Next, she wonders about chaos theory. In some secret zones, robots don't just flip coins. They use swirling fluids in tiny tubes. A drop of ink in the fluid can flow in 2 ways, left or right. That system is sensitive. A tiny puff of air in the lab can push the drop one way or the other. Mira realizes she cannot predict each drop's path. It's chaotic, but she can measure the tube shape, the fluid speed, and still estimate the chance of left or right in the long run. Mira steps back, so the random republic is partly predictable. After all, she says, on the big scale, we foresee averages and patterns, thanks to the statistics. On the small scale, single choices stay mysterious. Pure randomness or chaos at work. She smiles. The world can dance to random beats, yet still sing a familiar tune. In the end, her thought experiment shows that even a civilization driven entirely by probability reveals hidden rhythms. Individual steps may surprise, but the grand choreography lets us predict the show. Random or not, that's order in the art of chance.